Let's discuss the load calculation for multiple single-phase devices, specifically in the context of strip heaters. An engineering consulting firm is using a method where 8 2-kilowatt line-to-neutral strip heaters operating at 277 volts, with 3 on each of phase A and B and 2 on phase C are being treated as a single 3-phase device for feeder calculations. The formula they are using is current equals power divided by 480 volts times the square root of 3. The alternative is to treat each heater as a single-phase device, calculating the load on each phase individually and using the maximum phase current to size the feeder. This involves calculating the current on phase A as the power on phase A divided by 277 volts, similarly for phases B and C, and then selecting the maximum of those 3 currents. There are different approaches, and selecting the best one depends on the context and desired accuracy. The first approach, treating the heaters as a single 3-phase device, assumes a balanced 3-phase system where each phase carries an equal amount of current. The current is calculated using the formula current equals power divided by 480 volts times the square root of 3. Here, current is in amps, power is the total power in watts, which is the sum of all heater powers. 480 volts is the line voltage, and the square root of 3 accounts for the phase difference in a 3-phase system. The second approach, treating the heaters as individual single-phase devices, considers each heater separately. The current on each phase is calculated by dividing the power of the heaters on that phase by 277 volts. So, the current on phase A equals the power on phase A divided by 277 volts, and so on for phases B and C. The maximum of these 3 currents is then used for feeder sizing. Both methods have their place. The first method, the 3-phase approach, is more accurate when the heaters are truly connected in a balanced 3-phase system. The loads on each phase are relatively equal, and the system is not significantly unbalanced. The second method, the single-phase approach, is more appropriate when the heaters may not be connected in a balanced 3-phase system. The loads on each phase may be significantly different, or the system is potentially unbalanced. In the given scenario, where there are 8 heaters distributed across the 3 phases with some variation in phase loading, it's generally more appropriate to use the second method, that is treating the heaters as individual single-phase devices. This ensures that the feeder is sized appropriately for the actual loading, taking into account any potential imbalance between the phases. It provides a more conservative and accurate assessment of the maximum current demand on the feeder.